This video is looking at how you work out the RFM if you're given the mass and the moles of a compound, and then how you might identify an unknown part of a formula. So it's really good if you already know how to calculate RFM and you've had lots of practice at that, and also if you know how to find number of moles from mass and RFM, and if you know how to find mass and you're comfortable with rearranging that formula. So in our first example, it says a metal carbonate has the formula XCO3, and then it says that 0.25 moles of the carbonate has a mass of 21 grams, and then it's asking us to do two things: work out the RFM and also identify element X. And there are two bits of information numerically, this bit and this bit, number of moles and mass in grams, but there's also a formula which we're going to need to use. So X in this case is not an element that's on the periodic table. There is no element with the symbol X on its own, and sometimes they will use M instead, and that will be usually standing for a metal. And in fact, we're told in this question also that it's a metal carbonate, and so since carbonate is the CO3 part, I'm assuming that the element X is a metal, and that's going to help me out when I check my answer. So the first thing I'm going to do is think about the formula that links the mass with the RFM. So the mass in grams is equal to the number of moles times the RFM. But I'm being asked to work out RFM, so I can rearrange it so that RFM equals mass in grams divided by number of moles. And so my mass in grams in the question is 21, my number of moles is 0.25, and I get my RFM as 84. So far so good. Now what I've done, part of the question already, I've already got a mark for working out the RFM. So because I don't know what X is, I don't do what I normally would do to work out RFM, which is to go on the periodic table. I can't do that here because there's an unknown element. The next step is to work out what that unknown element is. So I've worked out the RFM. The RFM was 84. And what 84 equals is the RFM of XCO3. So if I was working out the RFM of XCO3, there was one atom of X, there is one atom of C, and there are 3 atoms of oxygen. So I can substitute in the numbers that I know. I know the whole thing adds up to 84. I don't know what X is, but I do know that carbon weighs 12, and I do know that oxygen weighs 16. So if I work out all of those bits that I do know, I know that 12, 3 times 16 is 48, so X 84 is equal to whatever element, mass of element X is, plus 60. Then I just need to do a little bit of rearranging. That tells me that X, the mass of X, is equal to 84 minus 60. So I can find out the mass of X is 24. The next thing I would do is go on a periodic table and look for the element that has the mass, make sure it's the mass and not the atomic number of 24. Then I would find that X equals magnesium, Mg. So that's the first example. You're given the formula, so you can just substitute. It's just a little bit of algebra. And the next example. 27.6 grams, so I'm given that information, and I'm given moles over here, 0.6 moles, and this time I'm not given a formula, I am just told metal sulfide. Okay, so I'm not going to worry about the metal sulfide bit for the moment, because the easiest thing I can do is work out RFM, because I just need to use the same equation I've been using throughout this topic. So this case RFM, mass in grams, is on the top, as it always is, divided by number of moles. And so in this case I have 27.6 divided by 0.6. You'll know if you've done this wrong, okay, because the point is that your RFM should be like a reasonable sized number. If you did it the wrong way round and divided the wrong things by each other, you'd get a number like 0.02. Now that can't be the RFM of a compound made up of different elements, because the smallest element weighs 1. If you times them together, then you would end up with a ludicrous number like 16.56. Again, that isn't going to work. You can't find atoms that add up to 16.56. So usually finding the RFM is easy to work out, because you're just going to do what you're just going to have to do the numbers that give you a decent RFM value, even if you've forgotten how to rearrange it. Okay, so I know the RFM of the whole thing equals 46. Now, if you're not told anything other than metal sulfide, sometimes metal oxide, etc., then we're just going to assume for the moment that there's only one sulfur atom. That is a safe assumption to make, because to do with bonding and everything else that we look at in later topics. So what I'm going to do is I'm going to find the mass of the metal that's in the compound. Now I know that the whole thing weighs 46, and I know that it also contains sulfur, so basically the mass of the metal must equal the whole thing, 46, take away the mass of sulfur. So I go on the periodic table, sulfur weighs 32, so 46 take away 32 is going to be, don't work it out in your head, 14. It's okay to work these out in your head, by the way, but if you use a calculator, it really is going to eliminate silly errors. It's very easy to just add 10 on or take 10 away or whatever. So the mass of the metal is 14. So it sounds like it's just going to be as easy as the last question. I just look for a metal that has a mass of 14 on the periodic table. Here's my periodic table. So I'm looking at the top numbers, the bigger numbers, those are the mass numbers. Okay, so if I follow along, I can find that there is an element with a mass of 14, nitrogen. And the less chemically aware of you would just go ahead and write that it must be nitrogen sulfide. But hopefully some of you are at least having some alarm bells and thinking, I don't think nitrogen is a metal. Here's my little step. Nitrogen is definitely on the right hand side. It's also a gas. I mean, it doesn't do anything that I'd expect of a metal. So when you get this problem and the mass does not add up to where you think it should be, one thing you should maybe do is check your calculation, because it might be that you've simply taken away the wrong thing, taken too much of the wrong thing away. But the other thing to do is think, well, what number goes into 14? Because we haven't been given the formula. So my formula could be XS, if X was my metal, but there's no reason really to suggest that it couldn't be X2S or X3S or so on. Well, it turns out that 7 goes into 14 twice, and that there is a metal, lithium, that does have a mass of 7. And so we can work out 14 divided by 2 is 7, which equals lithium. The formula of the sulfide would therefore be Li2S.